Hello everyone, and welcome back to Let's Make a Game. This is Snackrificial Chamber, episode 23, and today I'm adding two new track types. The first is called a painter, and it's used to change the color of the cargo passing over it. The second is called a laser grid, and this one destroys any cargo whose color does not match the color of the track. Let's get started. Once again, the first step in creating new track types is adding the tile types within the tile class. I added the painter and laser grid, both of which have standard output types and full rotations. Another bit of setup, I'm adding painters, so I need a few colors to paint with. I added some color constants for the 4 colors available to the painters, then added them to a list so I can retrieve them all at once. After those changes were made, I needed some new prefabs for these tracks. Using Blender, I created a structure that could be used both as spray nozzles for the painter and laser nodes for the laser grid. I made 2 copies of the conveyor belt prefab and attached the spray nozzle laser node model. I then swapped out the conveyor core material for a static base and gave each prefab a new sprite to help identify the tracks. On the left is the laser grid, and on the right is the painter. Next, I made a small change to the GameTile class and each of the inheriting classes. I added a GameCargo parameter to the activate method. Since I updated the method definition, I also need to update the call to this method within the checkPositionBehavior class. In order to change the color of the cargo objects, I needed to create a shader with several exposed variables that I can manipulate. Starting at the top, this line takes in a texture or color which sets the base colors of the cargo. This block at the left performs a lerp function between the original color and the next color based on a t-value from 0 to 1. Lerp is a fancy word for linear interpolation, and here's how it works. Say we have a start value of 0 and an end value of 10. We can connect these values by a line, and along this line, we can find all numbers between 0 and 10. Now, when we provide a t-value from 0 to 1, which represents a percentage, we traverse the line to get the result. If we give a t-value of 0.4, we travel 40% of the way from 0 to 10, which in this case is 4. If we give 0.7, the result is 7. This function can also be applied to points, i.e. coordinates of 2, 3, and 9, 7. If we use a t-value of 0.3, the resulting point is 4.1 by 4.2. And we can scale this up even further for colors which are represented by 3-dimensional points. After that crash course in lerp functions, here's the rest of the shader. The next block does the same thing. However, this one takes the color from the first lerp and uses that as the start point for the second lerp. The end point is a dark gray to represent a burnt color, and the t-value is the burn percentage. I then clamp the values so everything is between 0 and 1 and represents a valid color. Finally, I multiply the base texture by this calculated paint and burn color to get the final texture of the cargo object. To take advantage of the shader's exposed variables, I added some constants to the GameCargo class for each variable. I also added an array for all renderers within the cargo object and flags for both painting and burning states. I then added some methods that set these flags. The setColorIndex method, in addition to setting the painting flag, also sets the paint color on the shader. This color will be the endpoint of the first lerp function. On each update call for the cargo object, I find all of the renderers within the object if the array isn't already set. If the painting flag is set, I pull the painting percentage value from the shader, increment that value by delta time times a speed modifier, and finally set the percentage on each renderer to the new value. If the new value is greater than 1, I set the start color of the first lerp function to the paint color and reset the percentage to 0. This resets the lerp so the object can be painted again, but retains the color that was just set. In order to paint the cargo when it activates a painter, I created a new GameTile painter class that inherits from GameTile and overrides the activate function. This method calls setColorIndex on the game cargo that comes through as a parameter. The property A value of the tile is then converted to one of the available paint colors and begins the painting process. Here you can see several painters in action. Each of the painters here paints the cargo one of the available colors. Due to the way the shader works, cargo objects can also be painted multiple times. Now for the burning flag. Similar to the painting flag, I pull the current percentage value, increment it, then set it on each renderer. If the new value is greater than 1, I call the destroy self coroutine. When a cargo object is destroyed by lasers, it generates a message based on the type of cargo, then publishes that message to the lose level topic and causes a game over. Again, I need to create another new class to set the burning flag, this time called GameTile Laser. This one also inherits from GameTile and overrides the activate method. Finally, here's the laser grid. On the left, you can see the cargo is painted twice, and the final color matches the color of the laser grid. The cargo passes through it and is sacrificed on the ritual circle. On the right, however, you can see that the final paint color does not match the laser grid further along the line. When the cargo reaches the laser, it begins to burn and is destroyed, which triggers a game over. On a side note, I did create a way to change the colors of both painters and laser grids. If you're curious on how I did this, you can check out my video on the grouper since they work the same way. That's all I've got for today. I added 2 new track types that are used together to create a puzzle. The first track is a painter that changes the color of the cargo, and the second is a laser grid that destroys cargo whose color does not match the track. If you like this episode, you can subscribe to my channel on the left, or watch more of my videos on the right. If you have suggestions, you can leave a comment or reach out to me on Twitter. Thanks for watching.